Quality of Service Part 1, the QoS Fundamentals and the MQC. Have you ever been blown away by just a new invention that you've seen? My parents have this cabin up in northern Arizona. It's a nice little getaway. Anytime I just want to leave technology behind and kind of escape into, hunting and fishing and all that sort of world, that's where I go. The last place I'd ever find technology. But this last Christmas, I found it. I was sitting in their kitchen and my mother pulled out this little contraption from the drawer and she stuck it on this apple and I kind of sat there and stared and what's it going to do? She spun it around and sure enough, woof, the skin peeled off the apple like nothing. And all you were left with was the crunchy core of the apple. It was the best apple I ever had. Amazing. That's what QoS is to me. It's the new invention of the Cisco router. Yes, quality of service has been around for a long time, but we haven't really found much of a use for it until about the last 4 or 5 years when IP telephony and streaming video has really taken off. And over these next few nuggets, what I want to do is really lay for you the foundation of what quality of service is all about and how to implement it in your network. We're going to start off here with the quality of service strategies. Looking at your network, how do you design quality of service for a good corporate style network? How do you deploy it? We'll look at some implementation strategies that Cisco has as well. How do you set it up on the Cisco router? The one implementation strategy that everybody has really begun to latch onto nowadays is called the Modular QoS CLI, the Modular Quality of Service Command Line Interface. Look at that. It's an acronym for an acronym list. In this MQC, we have the ability to deploy every quality of service type that we want on our Cisco router. And in this nugget, we're going to focus in on classifying and marking our traffic, differentiating our traffic from all the other traffic types that we may find on our network so that as we get into the next couple nuggets, we'll be able to treat that traffic differently. But the first question you have to ask is, how do I design quality of service for my network? And what better way to start off with how it is out of the box? The best effort QoS design strategy. And I don't really look at it as a design strategy. This is just how it works without quality of service. You have no differentiation of traffic types. And wow, networks today, what a diverse set of traffic types that we have. With the internet on the rise and everybody jumping out to get there, you have web traffic, FTP traffic. I mean, the type of traffic, and you name it. What traffic has just about every network administrator cringed over in the last couple years? Peer-to-peer traffic. Oh, the Kazaa, the Napster, the BitTorrent, all these different applications that are out there to share applications around the internet, music files, video files, data files. They're tearing network bandwidth up. And with best effort, you don't have any differentiation. Everything is treated the same. It's the default queuing method. When you pull a router out of the box or a switch out of the box, they all treat traffic the same way, as it should. And this was the original design of the internet. When you look at the internet, every traffic is treated the same way. Once it leaves your network, you have no control over it. Now, that is changing in modern times with the advent of voice over IP, where service providers are now providing telephone service over their internet or data networks, and I'll talk more about that. The way I look at best effort is kind of like the postal system. When you send a letter in the mail, you don't really have much control over it. It's just going to be the best effort of the post office. They're going to try and get it to the destination. If it gets lost, well, that's too bad. It's the post service, not to put the post service down, but there's no guarantee on mail that you put in your mailbox. It may take 2 days, it may take 5 days. It's really the best effort of the postal system. So we need a better way than the best effort method. And one of the first quality of service design strategies to really come out and take hold is integrated services. You'll often hear it abbreviated IntServe. And it's still in use in plenty of networks today. What IntServe does is it carves out bandwidth for applications. There's a lot of applications that require specific amounts of bandwidth or need a specific amount of delay. It needs to get there from at this amount of delay, 50 milliseconds, 100 milliseconds. IntServe provides just that. It gives you guaranteed delivery. And the way I think about this is it's like buying a private jet, maybe a little better one than that, but a private jet for your traffic that you can say, anytime this certain type of traffic, maybe it's mainframe, maybe it's voice, maybe it's video, anytime that certain type of traffic needs to get from point A to point B, you have this jet to get you there. And it's going to be guaranteed. I'm going to carve out that bandwidth. So what's the problem with IntServe? I'm sure you can detect the tone in my voice that it's not the best way. Well, it is good. It does guarantee the bandwidth, but it's just not scalable. I mean, once you carve the bandwidth out and say this bandwidth is reserved for that application, that means no other application can use it. Take this example. If you take the private jet analogy, it's like saying this private jet is reserved for that traffic and no other traffic can use it. Well, if that traffic isn't using it at the time, by golly, that's a private jet just sitting there that nobody can touch because it's reserved. That's why IntServe isn't that scalable. Once you carve out certain amounts of bandwidth from your link that only certain applications can use, well, you're eventually going to run out of bandwidth, and whatever bandwidth is left over will have to be split up for the normal day-to-day traffic, and that's not good. Because as you get more and more of these applications with special requirements, your bandwidth on your links are going to be carved up so low that you get poor performance for the rest of your network. Well, that brings us to one of the newest and most flexible quality of service design strategies that's out there, and that is called differentiated services. You'll also hear it referred to as DiffServe. What this lets you do as the administrator is divide up all your traffic into different classes. So I can say class 1 maybe is web traffic and FTP, class 2 is my voice traffic, class 3 is video, and so on. We divide it all up. From there, you determine exactly how each one of those classes should be serviced. Take it back to that postal analogy that I was giving you earlier, because the post office doesn't just have one level of service. I mean, if you stick it in your mailbox, they do, but if you go into the post office, you get to say, well, you know, I want maybe first class service. Let me get my pen out here. First class service for some of my packages, and I want that to get there overnight. For some of the other packages, maybe the standard 2-day letter service delivery is okay, and then looks like this guy down here got the best effort treatment. There's a couple little dings and banged up on that box, but you get to determine exactly how each one of those boxes or each one of those packets are treated as it leaves your network. So you might be thinking, well, wow, I mean, why is IntServe around if you have this kind of flexibility with DiffServe? That's a good question. First off, a lot of people don't have routers that have the ability to support this level of quality of service. Maybe the router just has an older operating system or whatever the case may be. But also, differentiated services doesn't give you the level of guarantee that IntServe does. I mean, IntServe literally carves out the bandwidth. It uses a system called RSVP. You might have heard of that. It carves out bandwidth and says this 60 kilobits per second or whatever you designate is guaranteed for that application. Nothing else can use it. You can't match that level of guarantee because really the bandwidth can't be used for anything else. DiffServe gets close to that level of service, that level of guarantee, but doesn't quite get to that level. However, it's close enough that when you see how we configure differentiated services, I think you'll feel confident going, okay, that's the way I want to use. I'm going to take a turn into the QoS implementation strategies, but don't worry, I haven't left the design behind. Never has design been so important as quality of service because how you implement it really comes directly from how you've designed your network to handle the different traffic types. So while we will spend the vast majority of our time in all of the quality of service nuggets sitting in the configuration interface and setting it up, I'm always going to refer back and say, well, let's look at our design. This is how we've set it up. This is our strategy for deploying quality of service. So there's 4 different ways that Cisco gives us to deploy quality of service. The first one is the command line interface. And when I say that, that could encompass everything. You're typing on the Cisco router, right? Well, what I mean with that is the legacy method of implementing quality of service. It goes in an interface by interface basis. I go under my Ethernet interface and I say, for this interface, this is how I want to handle traffic. Do this, do that, do this, do that. I go to my serial interface. For this interface, this is how I want to handle traffic. Do this, do that, do this, do that. And I go for each and every interface and deploy quality of service on an interface by interface basis. It's still there. It still works. You can still do that in all iOS versions. However, it's not as scalable or easy to control and manage as the modular QoS CLI. This is going to be where we spend all of our time in all of the quality of service nuggets, because this is Cisco's preferred method to deploy quality of service. I'm going to leave the description of MQC for the next slide, because really to describe MQC just by a bullet point is too difficult. I want to make sure we talk it and give it justice with how it's deployed on a Cisco router. Auto QoS, I have a personal bias against. Auto QoS came out about 2002, 2003-ish. Cisco released this Auto QoS feature. And what it is just one command. One. You go on your Cisco router under the interface that you want to deploy QoS on, and you type in Auto QoS followed by an argument and hit enter. Poof. QoS is deployed. It's magical. We don't know what happened. It just applied a QoS template to that router or that switch. It goes against everything I believe with Cisco equipment, that you as the administrator should control it. You should deploy it. Auto QoS does it all for you, and guys, it's really good. I have to confess. Auto quality of service is a template system, but the nice thing about it is it ensures that you deploy quality of service in the ideal method and in the same method on all your equipment. See, as we get into MQC and even some of the CLI methods, you're going to see many different ways that we can deploy QoS. And the key is that QoS is as good as your weakest link in the chain. If you have one router that, oh, I forgot to do this, that, and the other, I forgot that MQC standard, or I forgot that bandwidth provisioning, that's going to be the weakest chain in the link, and that'll break your whole network. By using Auto QoS and typing that one command, you apply a template to your network that is the same across all equipment. You don't have that weakest link in the chain anymore. I'm going to show you Auto QoS, but I can guarantee you, let's spin it back to the CCIE, since it is just one command, Cisco isn't going to let you just type in that one command. You need to know what Auto QoS does, because when you type that one command, it'll take a while. You'll see the prompt hang for a few seconds. And then you go back and do a show run. You'll see a ton of different commands that it typed into your router for you. And a lot of them deal with the MQC. It'll apply MQC standards. So we'll look at that. Finally, the QoS Policy Manager, we're not going to touch it here because that is a plugin for Cisco Works. Cisco Works is a graphic way that you can manage your entire network. And for a service provider or an enterprise network, this might be the way that you go because it allows you to implement policies on a network-wide basis. But it has nothing to do with command line and requires that you buy Cisco Works to really manage your whole network. We're going to focus on these top 3 levels as we get into this. I want you to think about quality of service as a tool belt, because a lot of people put a blanket statement and say, oh yes, I've deployed quality of service on that router. Well, what does that mean? Quality of service is a big blanket statement that really encompasses, like a tool belt, you have a lot of tools. We see this big list of QoS mechanisms of classifications, marking, management, avoidance, policing, shaping, and link efficiency. And just think of it as a belt that has screwdrivers, wrenches, and I'm not a tool guy. It's a lot of tools inside your tool belt, right? So some of those tools can be used for different things. For example, I could use a flathead screwdriver to pry a nail out of a wall. But by golly, would it be a lot easier if I used a hammer and the other end of a hammer to pry it out? There's specific tools for specific things. And we're going to go through each one of these tools as we go through the quality of service nuggets and figure out where in the network it's going to be deployed. Now, a tool that just about everybody needs is a screwdriver. I mean, it gets the screws in, gets the screws out, helps you poke holes in things, can be used as a self-defense weapon, all kinds of things. That is like the classification and marking, and that's going to be what we talk about in this network, in this nugget. We're going to take a look at how to classify and mark our traffic so that we can tell the difference between different traffic types all throughout our network. And it is an all throughout our network kind of thing. You might have a user sitting up here attached to this network segment that sends a packet. Well, that packet might be a Kazaa packet, it might be a web packet, we don't know. We need to, as it comes into this first router, classify it to determine what kind of packet it is, and then mark it so that we know what packet it is throughout the rest of the network. So when we get to this point again, this router can go, oh, it's been marked with the color blue. I know how to treat blue packets. That's where we get into the other methods that we see here. Management, avoidance, policing, and shaping. These are the methods that the router uses that says, oh, I see a packet that's marked with a blue marking, or I'll get into what all the markings are. I'm going to treat it this way. These are all the different ways that we can treat our traffic as it goes throughout a network and eventually leaves our network. QoS mechanisms, you're going to see, can be applied in many different ways and really gets back to your design. I'm not going to leave that design behind. So as we go through each one of these mechanisms, definitely get a picture in your mind of where can I use this inside of my network. Well, I don't know a better way to talk about classifying and marking traffic than to get back to our friend, the Modular QoS CLI, or the MQC. Now, the first word of that is modular. That's what Cisco designed this to be. They've set up the MQC in a system that you as an administrator will go on your router and define class maps. Class maps have one purpose, and that is to match traffic, to figure out what kind of traffic you have on your network. It could be web traffic, it could be Kazaa traffic, it could be mainframe traffic, it could be all kinds of traffic types that are coming in. Class maps allow you to classify those into different groups. The policy map determines what do you want to do with those classes of traffic. For instance, we might have class map 1 that defines Kazaa traffic. I might say in my policy map that I want to treat Kazaa traffic this way. I want to limit its bandwidth, or I want to give it best effort delivery, or whatever you want to do. That's what the policy map defines. And I don't want to get into all the different methods because that'll be the job of the upcoming nuggets that we can limit or allow our traffic to get through our network. Finally, once you've defined your policy map, you can then apply it to specific interfaces. And we'll get more into this structure as we go through it, but I want to start off right here with the class map and tell you how we can classify our traffic. Now, this is a simple network, but it may very well be very complex. We might have many routers behind this Ethernet segment, or many routers beyond this WAN connection that this router is sitting in. I just want to focus in on one router to get the foundations of how we set this up down. So imagine that we had a client, and this is your average everyday client that I'm going to add to this network over here. And as soon as you add a single client, you open a whole world of application traffic. Let's imagine that this is the internet out on this side of the world. Now, that client can run web browsers, FTP clients, he could run Kazaa, BitTorrent, whatever file sharing application you want to throw in there, and start sending all sorts of traffic patterns through your router. Now, I think the best way to show you how we can classify that traffic is to actually do it. I'm going to bring up a router and get into global config mode. And the first thing, whenever you design an MQC standard, is to start classifying your traffic. So I'm going to make a class map followed by the keyword of match all or match any. Now, if you put just a word, that'll accept the default of match all. That means everything has to match underneath here. Match any means any of the criteria can match. And here's what it means. Under this class map, I can say I want to match by IP address. I can say I want to match by application type. I can say I want to match by access list specification. There's a whole list of criteria. If I choose match any, that means any of those criteria can match. The IP address or the application type or the access list criteria, all those, it's kind of an or. If I put match all, I have this and in there. I have to match that application and that IP address and that access list and so on and so forth. So in this case, I'm going to choose to put match any. And that way, it'll match any of the criteria, and I'm going to call this one junk_traffic. That's the name of my class map. Question mark, and I've got free game, so I hit enter, and I'm now in class map configuration mode. When I hit question mark, you can see I don't have many options. Description, exit, and match. That's the big one. I want to match certain criteria, and this is where my options come in. I can match by access group, which points us to an access list. So I can define an access list saying what port numbers or IP addresses I want to configure. I can match by class of service. That's a layer 2 marking. We have IEEE 802.1q and the ISL class of service markings. Here's the idea. We could have a switch, a Cisco switch, that has the power to mark at layer 2. So if we have a client attached at layer 2, as it comes into the switch, it can actually map it with a certain class of service, COS. Now those values can be anywhere from 0 through 7. And what that allows us to do is classify it right at the switch. I'm working on a router, so I've even gone a little further. We have a switch that's not shown here that we could have marked it with a specific class of service and even classified it earlier in the game. And sometimes that's your best bet. The closer you can classify it, the better you are. So I can say I want to match a certain class of service and maybe remark it up at a layer 3, because class of service is a layer 2 marking. I can match a specific destination address. You see this huge list. I can get into frame relay mappings and so on. But let me show you my favorite. Oh, you're going to love this. Match protocol. Let me paint you the vision. The vision is right now, firewalls as we know it are going away. And I say that because firewalls allow or deny traffic based on port number. So I can say, well, port 80 of TCP is allowed, and that allows web browsing. Well, here's the problem. Applications, especially peer-to-peer programs, have figured out how to tunnel through port numbers. That means that I could have, say, Kazaa that tunnels itself through port 80 of TCP, thus totally negating our firewall. Our firewall says, well, it looks like web traffic. It's using port 80, so I'm going to go along with it. Let me tell you this. Microsoft has already announced an initiative to allow the next version of the remote desktop protocol to use tunneled port 80. Here's what that means. Let me get back to my whiteboard and show you the devastation that this can cause. Imagine that this is the inside of your network right here, corporate network XYZ, and this is the internet. We have somebody on this network that's technically savvy, and they want to access their home computer. Now, you are a good network admin and realize that that could negate some security standards, so you deny port 3389 of TCP. That's the RDP, Remote Desktop Protocol. But with Microsoft's new initiative, why are they doing this? I don't know. Their new initiative says tunnel it through port 80. So this gets encapsulated in port 80 and sent out, and this client out here receives it and has no problem. Now, that user is accessing things out here that they should never be able to access, and will be able to allow themselves to get that data back into their network, which could spread worms, it could spread viruses. Oh, the sky's the limit. So I've defined the problem. Here's the solution. Match protocol. Now, it might not sound like much. Let me do a match protocol question mark. And we see in here kind of a list of protocols that we've come to know and love. Our IP ARP, BGP, bridging protocols, Cisco Discovery Protocol. Let me scroll down a little bit more. Fast track traffic. What's this? Kazaa, Morpheus, Grokster. These are peer-to-peer file sharing applications. Look at this, Nutella traffic, BearShare, Limewella, Notella. That's another group of file share or peer-to-peer applications for sharing files. Specific Kazaa. What is this thing? What is this help menu showing us? What it is showing you is Cisco's new combat to a lot of the port tunneling applications. It is called NBAR, Network-Based Application Recognition. I'll jot it on the screen behind us. NBAR. What this does is inspects packets, but it doesn't inspect them just for port numbers. It inspects them all the way up to the application layer. Holy cow! What does that mean? It means that the application can tunnel and change port numbers. I mean, you've seen FTP. FTP sites can change port numbers all the time. You can change port numbers as much as you want, but the application, that's what this A stands for, is still the application. NBAR recognizes things by application signatures. The application itself, all the way up to the application layer of the OSI model, is recognized by NBAR. So when I say I want to match FTP, you see FTP in this list, you think, oh, well, you're matching port 21. No, I'm not matching a port number at all. I'm matching the application itself. Do I sound excited about this? I am. It's life-changing for the firewall because they don't have to inspect port numbers anymore. They can watch for specific applications, and these applications are dynamic. They change port numbers. We don't care. We can catch them. We can classify them in our class map by matching a protocol. So as we go throughout all these quality of service nuggets, you'll see me match protocols all the time. Now I know what you might be thinking, because I thought the same thing. Does this impact the performance of your router? Not much at all. No more than a standard access list, because this integrates with something called IPsec, Cisco Express Forwarding, which allows all this to be cached. It affects your router no more than a standard access list. Now I know what you might be thinking as well. My mind snowballs just like yours. You might be thinking, okay, this is great. I'm looking at, let me scroll back up here, fast track traffic that has Kazaa, Morpheus, and Grokster, but what about the next one? What about when they come out with Kazaa version 10 or you know, LemonWire or something that's different that's not in this list? How do you handle that? Do you have to upgrade the iOS? I'm glad you asked. Let me jump back out here. I'll do IPnbar in global config mode, followed by PDLM. PDLM is actually a file that you can download from Cisco. It stands for Packet Description Language Module. They're free. And what you can do is copy them into the flash of your router. I could type in flash ://. As a matter of fact, let me pause this recording. I'm going to take you to Cisco's website real quick. Okay, I'm there. I'm at Cisco's website, and I've gone specifically to the nbar Packet Description Language Modules download area. Check this out. I get a grin on my face. WinMX, that's a file sharing application that wasn't in that list. BitTorrent, that wasn't there either. Gnutella. You see all these PDLMs, and you see the dates that they're coming out. These things are released as soon as the new applications are released. They're very small. They're 4 kilobytes in size or so. You copy these PDLMs to your flash. Then, let me just pick one right here. WinMX.pdlm. You type in IPnbar PDLM flash : WinMX.pdlm after you've copied it over from a TFTP server. It's not going to find it, but as soon as you do that, it's going to add that to this protocol list. Now when you do a match protocol ? From class map configuration mode, you'd be able to scroll down and you'd see when you got to the W's, you would see WinMX, another file sharing application. So it's expandable, which is a huge feature for a protocol like nbar that allows you to reach and add those new applications as they come out and allow you to limit those traffic. Now, we haven't even gotten into limiting. Remember, at this point, all we're talking about right now is classifying, matching these traffics and figuring out what class they fall in. We haven't even marked them yet. So let me get back into that. Actually, I hit the up arrow a couple times. Class map junk traffic. What I can do is I can say match protocol. I'm using nbar now. I'll do Kazaa version 2. I'll do match protocol fast track. That was the other one. Match protocol, and I'll add one more to that list. Protocol, and it was Gnutella. That matches pretty much all the P2P programs that are out there. So at that point, I have matched those protocols. Enter the next major part of quality of service. Now that I've classified them, that's what that match keyword is. You can almost think of this as a match map. After I've classified them, I now need to mark them. Let me clean all the gibberish off this whiteboard so I can have a little writing space. There we go. Now, when we're marking traffic at the router, there's really 3 ways that we can do it. We have the marking of the COS, or class of service. I already talked about that one. I'm going to keep that one in a different color, because we also have IP precedence. I'll put IPPREC, IP precedence, and DSCP, differentiated services code point. Here's the difference between all of these, and I'll try and keep it as short as I can because I could digress into these forever. COS is class of service. That is a layer 2 marking on your packet. So think of your packet wrapped in all its different headers and all its different pieces and so on and so forth. Right up front, we have the layer 2, and this is where you have your MAC addresses and so on. You can also have an area on the Cisco switches that support an area on that packet. That's the COS, class of service marking. That's a value from, as I mentioned before, 0 through 7 that you can mark it. So as it's traveling into the switch network, the switches themselves can actually prioritize traffic. Now, that's all I'm going to say about class of service, because On the switch side, it's not that big a deal. Congestion on switches are really temporary things. You have hundreds of megabits at your disposal most of the time, so congestion isn't going to last very long. Where it really does hit you is over here on the router side. That's where these other two markings come in. IP precedence and DSCP. Going back to this packet, these markings reside in the layer 3 area. There's actually an area, we have COS down here. At layer 3, we have TOS. It stands for type of service. Class of service is layer 2. Type of service is layer 3, because every time you go from the switch to the router, that layer 2 class of service is stripped off. So we need something that goes from router to router. That's what these IP press and DSCP are. They're values that you can put in that TOS byte. There's 8 bits that are available there. Now, IP press is the old way, or IP precedence, I should use the full word. IP precedence is the old way, and that allows you to have values from 0 through 7, just like class of service. It works and allows you definite prioritization. However, we have more than 7 classes of traffic, and when you really look at it, at our disposal, we can use values from 0 to 5. That's what Cisco recommends, because 6 and 7 are reserved for network use, things like routing protocols and so on. DSCP, on the other hand, gives us values from 0 through 63. That gives us a lot more flexibility with what we can mark our packets as, because really you're never going to use 63 different classes of traffic, because you don't usually have more than 63 groups of traffic. I'm not talking about applications, I'm talking groups of traffic. You saw that I grouped all the P2P applications under one class called junk traffic. So we have these different ways of marking our packets. Depending on the router platform and iOS you have, you could use one or both of these for backwards compatibility purposes. Now, at this point, what are these values? I've kind of talked about the marking, but what are these values? All they are right now is a marking. I want to make sure you realize that. I can mark something with IP precedence 1. I could mark something with IP precedence 7. As of right now, if we just mark it, it doesn't matter. The router will say, hey, you have IP precedence 7. That's great. I'm going to send you the same as I would IP precedence 1. Marking the traffic is step 1 of quality of service. We have to differentiate between all these traffic types. Step 2 is going to be in the next nugget, where we get into how we can start using those markings and kind of differentiating between them, saying, well, I want to prefer type 7 traffic over type 1, and I want to send more of this than I do this. And that's when we're going to start getting into queuing and congestion management purposes. But for now, we're just going to talk about marking. I'm going to bring you back to my router, because I just created a class map. Let me do a show class map. And right here you see that I have junk traffic, ID 1. And under there I have FTP, which I guess we could consider junk, Kazaa, Fast Track, and Nutella, all my P2P applications. It also has a class map that's class default, that's in there by default, that matches any traffic. And you'll see where we can use that when we get into the queuing areas. But now I need to mark it. I've classified it, but it doesn't do anything with that traffic. It just says, you fit this class, good for you. To mark it, I need to go down to the second phase of this, the policy map. I'm going to jump in here and I'm going to type in policy map, and we type in a name. Let's name it marking. I'm now in policy map configuration mode. And from here again, you can see my options are very limited. I don't have much other than class. Class now allows me to designate what class I want to apply this to. Now, case and spelling does count here. So I'm going to use a copy, do class, paste. I type in class junk traffic. So what am I doing here? I'm getting deeper into these configuration trenches. I have a policy map named marking, and I'm saying under this policy map for the class junk traffic, and then here are my options. A lot of these are going to be in the upcoming 2 nuggets, actually, where we start talking about the bandwidth and giving them priority and so on. But for now, I'm just going to be using the set commands. I'm going to type in set followed by, and this is where I can set my marking. I can set the IP precedence or the DSCP. Now you can see there's other values I can set, and that goes far beyond what we want to do here. I can set MPLS values, I can set IP specific values. Really the only 2 I'm concerned with, and I guess we could say 3, is IP precedence DSCP, and there's that class of service if I want to do that. Now we're working up at layer 3, so let's set the precedence. I want to set the precedence, and there's my values, 0 through 7, and what I can do is I can also use a keyword. I don't like keywords because you have to remember them. However, I have heard through the grapevine that knowing these keywords can be an important thing. So if I want to type in set IP precedence, I want to set it to 5, I would type in 5, but that's the same as typing in set IP precedence to critical. Okay, that's the highest level that Cisco says you should be assigning things. If I was referring to things like voice over IP or video traffic, I would probably use an IP precedence of 4 or 5, which are very high up on the scale. But I'm referring to junk traffic right now, and I'm going to make sure that it always has an IP precedence of 0. That way, further down the line, which if I have one router, it's going to be as I leave this next interface, further on down the line, I can say all the stuff with IP precedence of 0 either gets dropped or gets severely limited as it leaves that interface. So I've said for junk traffic, that class, I want to mark it with an IP precedence of 0. Let me get back out of here. And I'll just do a show policy map and hit enter. You can see there's not much to this policy map right now because we're not doing anything other than marking. But I'm saying for the class junk traffic, set the precedence of 0. Let's make this a little bigger scenario before I apply it to the interface. I'm going to say class map, and I'll say important traffic. And I'm going to match the protocol. Let's find some important protocols. IPsec, that's a good one. That's going to be my VPN traffic. So if I ever have VPN traffic, I'm going to match that. Scroll on down through this list. RTP, that's a big one as well. Now, I wouldn't usually group those two traffic types. They're totally different. RTP is streaming audio. That's if we have voice over IP, it's going to actually match the streaming audio, the audio streams that are coming from the phones. So I now have two class maps. I'll do a show class map here. And right here I have important, and you can see I left it at the default, which is match all. So I'm matching streaming audio over VPN connections or using IPsec because I didn't type in match any in that case. And that's okay. We're just using it for the example. I'll do a policy map of, oh goodness, show policy map of marking. That's what I named it. Policy map marking. And now I'm under here. I'm going to type in class important. And for this class, I'm going to set, let's say, the IP precedence. And I will say, this is very important stuff, so I'm going to set it to 5, the maximum I should ever set any traffic. Now if I do a show policy map, you'll see it's grown a little bit. It's saying policy map marking. For the different classes, I have junk traffic, set it to 0, important traffic, set it to 5. Now do these arrows make sense? You can see that I have these policy maps that can apply to multiple class maps. But since they can do that, I only need one policy map to really handle multiple classes of traffic. Now in this nugget, we're only doing marking, so the final thing I have to do, I've identified my classes, I've set the policy, now I have to apply it to the interface. And in this case, I'm going to go into interface fast Ethernet 0 on this router, which is the incoming interface, and I'm going to do the command service policy, and we can apply it on input or output. In this case, I'm going to do input, because I'm having this policy map as things come in to this router. Think of it from the router's perspective. As it comes into the router, I want to classify it with that N-bar with match protocol, and then I want to mark it using my policy map. So say service policy input marking. That's the name, and let me just show you with the context sensitive help so we're following along. That's the name of my policy map. Again, case and spelling sensitive. So I hit service policy input marking, poof. I am done. I have now hit my first phase of quality of service by classifying and marking traffic. Now this is kind of fun because we can verify it by typing in show policy map, which shows us our policy map, but we can expand it and say interface fast Ethernet 0. Now what you can do is you can actually watch as it starts matching these packets. Now this router doesn't have any live traffic going through it, but if it did, it could actually watch it as it's matching each one of those packets, and you can see how many packets, how many bytes, how many bits per second it's using up over a 5-minute rate. That's some really cool monitoring information. I mean, without a protocol monitor, it's pretty nice to be able to do a show policy map and find out just how many bits per second of each one of these traffic types you're getting through your router. So you can start sending out those emails saying, excuse me, company policy says not to use these applications. So this is a really nice feature, and NBAR does even more on the monitoring side as well, but we're not here for that side of things. We're here for quality of service. Well, let's wrap this nugget up so we can get into the advanced quality of service in the upcoming nuggets, where we can take those classifications, we can take those markings, and now do things with them. We can have this help this faceless lady. That's just disturbing. This lady here who's juggling all the different traffic types. She now knows what those traffic types are. We might say, well, that's internet traffic, that's NTP, time protocol traffic, and that's application traffic. We've classified them, we've marked them, and now we're going to be able to do things with them in the upcoming nuggets. We also, in this nugget, took a look at the design strategies. And just to review, we saw the best effort, where we just allow these traffics to have at it and go through the router with no holds barred, and that's how they are by default. We saw IntServe, or integrated services, which carves out pieces of bandwidth. Then we saw diffserve, which allows you to classify and mark packets as it is to each specific class and then treat them differently. We also saw the implementation, where we got into the command line interface, which is the old way of doing it. Most of it focused right around this, the modular QoS CLI. But as we wind down with the QoS nuggets, I'll finally show you my loathed method of auto QoS, because it does it all for you with one single command. Those are all the different implementation types that we can use on our Cisco router. I hope this has been informative for you, and I'd like to thank you for viewing.